Hello students. Welcome to our Senior Secondary School 2 Physics lesson. Today, we will be learning more about machines. A continuation of our previous lesson. But before we proceed, let's quickly recap what we learned in our previous lesson. In our previous lesson, we defined a machine and found out its purposes. We identified various types of simple machines, their classifications, uses and applications. We also explored mechanical advantage, velocity ratio, and efficiency, and it was very exciting. Before we begin today's lesson, let's take a quick look at our lesson objectives. By the end of today's lesson, our aim is to learn about other types of machines and their uses, and also explore simple machines and complex machines with their examples. Are you ready? Let's proceed. Let's continue with learning about other types of machines. One of them is screw. It is an inclined plane wrapped around a cylinder or cone. It converts rotational motion to linear motion, and also multiplies the force applied to it. This means circular motion is turned into straight line motion. It is used to hold objects like wood, metal, and plastic together. The simplest example of a screw is a nut and bolt. As the nut is turned, it moves along the thread of the bolt as though it's traveling up an inclined plane. Applications of a screw. Construction. Screws secure parts in buildings and machines. Home appliances. It is found in blenders, fans, and washing machines. Next we have wedge. These are two inclined planes joined together to form a sharp edge. It concentrates force into a smaller area to split or cut materials. Examples: knife, axe, and chisel. Applications of wedge. The blade of an axe is a wedge used for splitting wood. A wedge-shaped object is used to keep doors open by wedging under the door. Food preparation. A knife, when applied to vegetables or meat, acts as a wedge that helps divide and cut it in bits. Now, wheel and axle. A wheel and axle is a simple machine, consisting of a larger circular wheel attached to a smaller cylindrical axle. Both parts rotate together, and the system reduces the force needed to perform work, by increasing the distance over which the effort is applied. It reduces friction when moving objects, making tasks easier. Parts of the wheel and axle. Wheel. The larger circular part, where the effort is usually applied. Axle. The smaller cylindrical part, where the load is often placed. For each rotation of a wheel, there is a complete rotation of the axle. Examples: doorknob, rolling pin, and bicycle. Applications of wheel and axle. Trolleys and shopping carts use the wheel and axle to make transporting heavy loads easier. The wheels reduce friction, and the axle helps bear the load. Wagons and trains. Trains use large wheels on axles to move along rails. Now, the hydraulic press. Hydraulic press is a machine that uses Pascal's principle to generate high force for compressing materials. It consists of a hydraulic system that amplifies force using a liquid medium, usually oil. Pascal's principle states that when pressure is applied to a confined fluid, the pressure is transmitted equally in all directions. A hydraulic press is used in various industries for shaping, compressing, and molding materials. Applications of a hydraulic press. Car crushers. Used in junkyards to crush old vehicles. Juice pressers. Extract juice from fruits using hydraulic pressure. And coin minting machines. This presses metals to create coins. Now let's talk about simple and complex machines. Machines are categorized into simple and complex, based on their structure and function. Simple machines are basic tools that make work easier. They have few or no moving parts. They either change the direction of a force or reduce the magnitude of effort needed. For example, a ramp, inclined plane, aids with pushing a heavy box up, instead of lifting it. Now, complex machines. They are made up of two or more simple machines working together. They have many interconnected parts and are often powered by electricity or fuel. They perform advanced tasks efficiently. For example, a bicycle combines a wheel and axle, levers, pedals, and gears to move efficiently. Key differences between simple and complex machines. Simple machines are basic tools that reduce effort, while complex machines are a combination of simple machines for complex tasks. Simple machines work manually, while complex machines are often powered by fuel or electricity. Simple machines are easy to use and maintain, while complex machines are more advanced. Machines are important because they save time and effort. They allow humans to accomplish tasks that would otherwise be impossible. And they are found in many tools and machines used daily. Well done, you are doing amazingly well. Now it's your turn. Here's a quick practice problem. Ensure to pause the screen or write out the given task to solve the problem. Assignments help you to gain a stronger understanding of a topic. Give it a shot. Great job so far. Let's recap. Simple machines make basic tasks easier. Complex machines combine multiple simple machines to perform more advanced work efficiently. Hydraulic press operates based on Pascal's principle. In our next lesson, we will be learning about friction. Well done. You've come to the end of this lesson. Keep practicing what you've learned. I will see you in the next lesson.